All right. Good afternoon, everybody. Happy Friday. Happy Friday. And it's a beautiful day for a change. Actually got very hot. Started off cold, and even though we're not down to the official date, we're officially in fall. Cold mornings, hot afternoons. We are in fall. All righty. We are going to start nitrogen today and do a quick recap on carbon. Give it another minute for 2 or 3 more people to join us. So I'm going to Canvas right now. I'm going to look at the nitrogen lesson. So if you would take a look at that on folks to join. All right, so again, we're looking at the nutrients that get cycled through an ecosystem. And carbon was the main one because carbon, I'm going to get down here to the previous. Um, we are carbon creatures. We are organic creatures. And so a lot of the storage with carbon is in living things. Okay. All living things are made up of some type of carbon compound. Carbohydrates, lipids, proteins are all what we call organic molecules. Anything that doesn't have carbon in it is an inorganic molecule. So it starts up in the atmosphere as an inorganic substance, and we find ways to incorporate it in the foods we eat. Plants take it in directly. We don't. While we inhale, and then that's something people get confused about. We inhale carbon dioxide when we breathe because it's in the atmosphere. We inhale a lot of things because air is a mixture of gases. So we take a deep breath, and then our body is able to dissociate what it needs and what it doesn't need. So it removes the oxygen from the air, and then we just exhale everything else back out. But in addition to the things that we exhale, we create carbon dioxide as a waste product of respiration. Okay, so that's something you need to remember too, that air is a mixture of gases. It's got nitrogen, carbon dioxide, it's got water vapor, it's got some other little particles, trace elements in it, as well as oxygen. In fact, oxygen is not the most abundant gas in the atmosphere. Nitrogen is. So we're going to look at nitrogen next. And that's one of the points about that, is that nitrogen is actually the most abundant element. But we don't get our nitrogen by inhaling it. Okay, we have to consume it in the foods we eat. All right, good afternoon. Welcome, welcome. I think we're only missing one person. All right, so again, we are looking at the fact that nutrients are cycled through our ecosystem. There's nothing new on the planet. Everything has been here since the beginning of time, and it just gets recycled over and over again. Okay, so hopefully you finished your carbon unit, you finished your um, carbon gizmo. The thing that to remember with the carbon cycle is this equation for photosynthesis and respiration. So this one right now is showing photosynthesis, where the carbon dioxide is taken in by plants or of some sort, green plants, and it is combined with the water that they take up through the roots. Does a nice little chemical rearranging, and all of the molecules change places. When you take chemistry, you'll learn that nothing is created or destroyed again. It is perfect balance. If we start off with 6 carbons, we end up with 6 carbons on the other side. So, I'm not going to get into balancing, but if you look real close, you got 6, that big 6 in front. says that there are 6 carbons and there's 12 oxygens. If you go to the other side, that there's also 6 carbons and you got 6 oxygens. Actually, you got the oxygen with the water too, so there's 6 over there. There's another 6 with the glucose, and then there's 12 with the oxygen that is released during photosynthesis. Okay, so there is a balance. There's nothing, they just change places. They do a little chemical dance and they create new substances with the same molecules they started with. Okay, and so that's photosynthesis. The thing that you have to remember is respiration is the reverse. So learn one equation and then just remember one is the reverse of the other. The important thing is to remember which one is which. Okay, so photosynthesis made carbohydrates, sugar, glucose. It gave off oxygen. So in respiration, you take in oxygen, you take in the glucose in the foods that you eat. With plants, they make the food and then they turn around and use that glucose that it just made for respiration. Okay, so it makes its food and uses its food. And so then they take in oxygen. There we go, 100% attendance. All right, so they take in the oxygen from the atmosphere, and again, they do that chemical dance, rearrange the molecules, and in respiration, we give off carbon dioxide back into the atmosphere and water vapor. So we exhale water vapor. Okay, so when you go huffing on a mirror or a glass or something, that's water vapor that you exhale. All right, so what else do we want to remember? Remember that decomposers are part of any cycle. They are necessary because things die and they just remain on the soil. If we did not have decomposers, things would just be piling up on the soil and not going anywhere. So decomposers, they feed off of the things that die, but they also return these nutrients back to the soil. So the carbon is returned to the soil that way. It's also released as a gas and returned back into the atmosphere that way. Under decomposition, let's see, weathering. So if it's something that gets stuck in the rocks, and as it does in limestone and sedimentary rocks, then the weathering process will wear it down and release it. Combustion, when we're burning up everything these days. So make sure you know this word, anthropogenic. They like that word. So make sure that you are aware of what that means. Okay. So if you haven't read this little paragraph, make sure that you, again, I'm always going to be trying to give you tips on how to answer a question. And you want to make sure that you use, not only use the word, but use it correctly. Okay. So let's see, what else? All right. Reservoirs are places where it's stored. They hold them for long periods of time, such as fossil fuels. Those are the ones that are long periods of time and then have to be burned to be released. Okay, down here it says memorize one, like I said, and the other is the reverse. Okay, all right, so that's the quick review of carbon. So we're doing nitrogen today. Nitrogen is another element on the periodic table. Again, like it is what we call a diatomic element, which means it doesn't travel by itself. It's 8% is nitrogen. All right, so I'm going to stop touching on all these points. And again, this is the cycle that we're going to have to know. I'm going to let Mr. Sneeds explain all that to you, and then we'll come back to looking at Canvas.
Today we'll be covering topic 1.5, which is the nitrogen cycle. So just like our coverage of the carbon cycle yesterday, we'll be focused on the sinks, sources, and reservoirs of the nitrogen cycle. But throughout the video, we'll point out how the nitrogen cycle differs from the carbon cycle in some really important ways. Our objective today is to be able to explain the steps and reservoir interactions in the nitrogen cycle. And the skill that we'll be practicing with the FRQ at the end of the video involve explaining relationships between different characteristics of environmental concepts that are represented visually. So
All right, so I'm pausing there because I have put the FRQ for this one and carbon together in your assignment folder. So we'll look at that when we're finished. So again, pay attention to what he just said so that you'll be able to answer that question that he's going to present at the end of the video.
we'll continue that focus on visual models like we did with the carbon cycle yesterday. So just like with the carbon cycle, the nitrogen cycle is the movement of nitrogen molecules between sources, sinks, and reservoirs. As a reminder, the sources are things or processes that release nitrogen into the atmosphere, and sinks take in increasing amounts of nitrogen.
Empower your students to be more authentic, impactful writers with Grammarly's comprehensive AI writing assistant.
Now, a big key difference between the nitrogen and the carbon cycle is that nitrogen reservoirs generally hold nitrogen for a relatively short period of time when compared with the carbon cycle. In the carbon cycle, that could hold carbon for millions of years. In the nitrogen cycle, most of the reservoirs are going to hold nitrogen for a relatively short period of time. So we can look at some examples such as plants or soil or the atmosphere. So plants are only going to hold nitrogen as long as they're alive. Then when they die, the nitrogen is returned to the soil. And that nitrogen does not stay in the soil for very long because it's taken right back up by plants for growth. Nitrogen also exists in the atmosphere. In fact, that's the biggest reservoir of nitrogen. About 78% of the atmosphere is made up of nitrogen. And a really of N2 gas. Now, this is not a form that's usable by plants or animals. Our final key detail here to know about the nitrogen cycle is that nitrogen is a key limiting nutrient for plants and animals. So all living things need nitrogen in order to make the DNA that goes in every one of their cells and to make the amino acids that build the proteins that their bodies are made out of. And so we have kind of a problem here, and that's that all living things need nitrogen. And the atmosphere is the biggest reservoir of nitrogen, but almost all of that nitrogen in the atmosphere exists in N2 gas, which is not usable by plants or animals. So the answer to this question is nitrogen fixation. It's the first step in the nitrogen cycle, and it is the most critical for life on Earth. So it's the process of this nitrogen gas from the atmosphere being converted into biologically usable nitrogen, which is a form that can be taken in.
All right, I'm going to pause it right there because that's important. The whole process, like you said, nitrogen gas is not usable by living things, so they've got to convert it. So this step right here is the most important step.
Plants, and that's NH3 ammonia or NO3, which is nitrate. So this can happen in a few different ways. It can happen both naturally and synthetically. Naturally, it can either be done by nitrogen fixing bacteria or by lightning storms, which can actually cause some of that nitrogen in the atmosphere to be converted to ammonia, but it's primarily done by bacteria in the natural sense. So we'll talk about two different types of bacteria that can do that now. First is bacteria that live freely in the soil, and so we can see that in the diagram if we look here. There are nitrogen-fixing bacteria that live in the soil. They can convert nitrogen in the atmosphere into ammonium, but there are also bacteria that live in symbiotic relationships with certain plants. Now, those are going to be plants that are known as legumes. So those are species like peas and beans. They actually have little nodules in their roots that the bacteria live in, and the bacteria fix nitrogen for these plants in exchange for amino acids that they use to build the proteins they need. So remember, symbiosis is a relationship where organisms are living closely with one another, and in this case, it's mutualistic because it benefits both species. So that's a very important form of natural nitrogen fixation. So if we look at the diagram, we'll notice this blue arrow around atmospheric nitrogen. Again, it can be done by lightning, but it's primarily done by bacteria, whether that's bacteria that live freely in the soil or bacteria that live in the root nodules of certain plants. Then we also have synthetic nitrogen fixation, and this is where humans combust fossil fuels in order to fix nitrogen gas from the atmosphere into nitrate. So this is NO3. This is very energy intensive, but it allows humans to produce synthetic fertilizers, which contain nitrates, and then we can spread over our crops to increase our agricultural yields or the amount of food that we produce. So if we look at the diagram here, we'll see in red, we have this factory to symbolize that this is an industrial process. Remember, it requires a lot of energy input, and then it's going to produce nitrates, which we'll use as fertilizers in agriculture. So while nitrogen fixation is a critical step to understand, and we spent a lot of time focusing on it, there are other steps in the nitrogen cycle that we'll talk about now. So the first one is assimilation. Assimilation is the process of plants and animals taking nitrogen in and incorporating it into their bodies. So remember that they need nitrogen in the DNA in their cells. They also need it to build the proteins that make up their bodies. So plants are able to access nitrogen directly by having their roots either take in nitrates or ammonia from the soil. Animals, though, have to eat plants in order to get their nitrogen. Or if they're a carnivorous animal, they need to eat animals that have eaten other plants. So it all starts with plants. They are the key assimilators of nitrogen. So if we take a look at the diagram, we'll see in the blue circles here, nitrogen is going to move from the soil into plants' roots and into the plant's body, and then animals will eat the plant, and that's how they assimilate nitrogen. Then we have ammonification. Ammonification is kind of the opposite in that it is soil bacteria, microbes, and decomposers converting waste and dead biomass, so dead organisms, and dead biomass, so dead organisms, back into ammonia that returns to the soil. So just like in the carbon cycle, we had the cycling of carbon between photosynthesis and respiration, we have something similar in the nitrogen cycle where organisms assimilate or take in nitrogen, but when they die or produce waste, then the bacteria in the soil and the decomposers break that waste down and they turn the nitrogen that was in the biological matter back to the soil through ammonification. So if we look at the circle in green here, we can see again these dead animals, dead plants, or their waste just gets returned to the soil to ammonia by these decomposers and other soil microbes. Next, we'll talk about nitrification. Nitrification is the process where ammonium, NH4, is converted into nitrite, or NO2, and then eventually into nitrate, NO3. Now, this is also done by soil bacteria. So I hope you're sensing a trend here in the nitrogen cycle, and that's that bacteria are very critical at almost every step of the process. So we can see that process of nitrification outlined here in the orange circle. And then finally, we have denitrification. Denitrification is the conversion of soil nitrogen, specifically nitrate, back into a gas form. However, this is going to be the gas form nitrous oxide, or N2O. And so this is going to be converted again by bacteria, released into the atmosphere, and eventually that nitrous oxide can break down to form nitrogen gas, and we've completed the cycle. Now we'll
Those eyes, that nose, your hair, your Nana's smile.
Now we'll wrap up by talking about some human impacts on the nitrogen cycle. So humans have an impact on the climate through the nitrogen cycle by the release of nitrous oxide. Nitrous oxide is a greenhouse gas, which means that it traps heat in Earth's atmosphere and warms it up. Now it's produced by agricultural soil. So when humans clear land and till the soil to plant their crops, the bacteria in the soil are going to, through denitrification, turn the nitrates in the soil into nitrous oxide. This is especially prevalent when the soil is waterlogged or over-irrigated. And so by the growing and production of human food, we contribute to greenhouse gases, particularly nitrous oxide. Then there's ammonia volatilization. So this is where excess fertilizer can lead to ammonia gas actually entering the atmosphere. This creates a couple issues. One is acid precipitation. So the ammonia can combine with water in the atmosphere, fall to earth as acidic rain, and that can create a lot of environmental issues. And there's also a human health consequence. Ammonia gas in the atmosphere can combine with other pollutants and can irritate the respiratory tracts of humans. And it's also just lost nitrogen from the agricultural fields themselves, which results in lost profits for farmers. And finally, we have the issue of leaching and eutrophication. So when we use synthetic fertilizers, we're often over applying nitrates to the soil, and we're putting more nitrates in the soil than it can hold. So this leads to something called leaching, which is where rainwater or irrigation water carries the nitrates right out of the soil. Think of it as kind of washing them or flushing them right out of the soil. And that agricultural runoff can enter local bodies of water like streams or lakes. And what happens is all of this excess nitrogen fuels aggressive algae growth to the point that the algae covers the surface of the water, and it actually blocks the sunlight so that aquatic plants below the surface don't get the sunlight they need, which can Q 1.5 today. We're going to be looking at explaining the relationships between different characteristics of an environmental concept. So I want you to try to describe one chemical transformation that occurs in the natural nitrogen cycle, and then explain the importance of that transformation to an ecosystem. All right, everybody. Thanks for tuning in today. Don't forget to like this video if it this is going to be.
And actually, I'm going to switch back to Canvas for this. But the question, like I said, I copied the question and it's going to be in Canvas. So I'll take you there in a minute. But this is a slightly more complicated cycle. Not slightly, it's a definitely more complicated cycle than the carbon cycle. And you see, you've got a lot of big vocabulary words as well. So you got to remember nitrogen fixation. You've got to remember assimilation, ammonification, nitrification, and denitrification, and then it back into the atmosphere. Get a little chemistry here. You got to know the difference between a nitrite and a nitrate. So if you look very carefully, a nitrite is NO2 and nitrate is NO3. And ammonia is NH4. So you got to know a few chemical molecules with this cycling of nutrients. Okay, but that's about it as far as chemistry is concerned. Okay. All right, so we're going to switch back to, oops, not attendance. Canvas. All righty. All right, so again, they've given you a little chemical background as to the structure, atomic structure of nitrogen. Later on, when you do chemistry, you'll learn that the electrons on the outside are the ones that share, and they share because everybody wants to have a full outer ring. And when they share, that's what causes them to be N2. And the same thing with oxygen. We always talk about O2, N2. Most gases, H2, they don't exist by themselves. They share with another molecule like themselves, and we call those diatomic molecules. All right, so it is important. It is DNA is a nitrogen-based molecule, so it's very important to our genetic makeup. All right, so this is the one I want you to study. I want you to take a few minutes to study this cycle. Go through each of the phases as he described it, and remembering that the nitrogen starts in the atmosphere, and then follow the path of the arrow. The first stop that is the bacteria in the soil. So this picture is showing bacteria in the soil. They are the ones that fix that they take the nitrogen and they fix it and create a molecule that the plant can absorb, and it absorbs it through the roots. All right, so then the plant has now incorporated this nitrogen into its structure. The rabbit comes along and it eats the plant. And so now that nitrogen is in the rabbit. The rabbit then dies and decomposers will break it down and return some of that nitrogen back to the soil. So you got a couple of pathways here. So you've got the nitrogen can be fixed by the bacteria in the soil and create ammonia and do the nitrification and form the nitrates and go back up and form the create something that the plants will use. The decomposers also break things down and create ammonia. And the nitrates are the ones that you have another set of bacteria that are going to break them down so that it can be returned back to the atmosphere. But most of it, notice, stays in the soil. It's happening in the soil, and it's between the plants and decomposers. So study this cycle, go through the phase descriptions. And again, a lot of vocabulary words. Please make yourself comfortable with those vocabulary words. And then let's look at the FRQ. All right, somebody's already done it. Let me look at this as student view. All right, so you should have on your page carbon and nitrogen FRQ. All right, so these are the two FRQs that are at the end of each of those videos. And so the first one worth 3 points. You want to first identify the process by which the diagram, so look at the diagram, study the cycle, identify one, hold on. No, but you can enlarge that. So remember, there's several processes. Let me go back to the module for a minute. Talk about carbon. When we say identify one process, carbon cycle. All right. All right, in the carbon cycle, you have carbon dioxide in the atmosphere. That's one stage. You have weathering of the rocks. You have carbon in the soil that can be weathered away. You can have it stored as fossils. You can have it leaving as leaching runoff. You can have it by photosynthesis. That's a big one, photosynthesis, respiration. So pick one of those processes, one of these stages in this cycle, and talk about, so let me go back to the question. Okay. Pick one that happens quickly. In other words, not one that's stored over a long time. So we talked about reservoirs. We're not talking about a reservoir, a process that happens quickly, and then one that happens slowly, like the reservoirs. All right, so that's the first part of the question. Then talk about how the rate at which the fossils are transferred into the atmosphere as shown in the diagram, has altered carbon dioxide during the past 250 years. So what are we doing to add more carbon dioxide into the atmosphere? There's a natural way. In other words, the diagram is showing the natural way that carbon dioxide should get into the atmosphere. But what are we doing in the last couple of years that is increasing the amount of carbon dioxide in this cycle? Okay, so that's that question. All right, the next question. Describe one chemical transformation that occurs in the natural nitrogen cycle, and then explain the importance of this transformation. So again, pick one of those words that has a chemical reaction going on and explain why that part, in other words, this is a cycle. Why if we take that part of the cycle out, what effect would that have on the ecosystem? Okay, remember all the cycles are like a circle of life. If you break the chain, what happens? Okay, all right, so I'm going to leave you to read to answer that question. Also, most of you have done the FRQs, not the FRQs, the MCQs in the AP Classroom. If you have not, nitrogen should be completed today. So do that one first. So do the AP Classroom first, and then come back and do the FRQ. Okay? All right. Any questions? Any questions? All right, so there's a couple of things. If you haven't finished your carbon gizmo and submitted that, you need to make sure you do that. The FRQs, because today's Friday, so they kind of update the grade book on Fridays. So make sure that you have done these 4 things that are on your to-do list. Okay? And if you have done that, then you're up to date. Great. Also, if you haven't done the assessment for the gizmo, please make sure you go back and do that. So you had to turn in a worksheet and do the assessment and the grades being added together. right, Abigail, are you there? All right, so there's a couple of things that you need to be doing. You need to, if you haven't completed the 1.5, and that's half of you in the AP classroom, start with that. If you have not turned in your Gizmo activity, do that next and take the assessment and then do the FRQ after that. All right, today is tutorial day, so I will stay on past 1:30 for those of you who might need help or need me to open something or need assistance with an activity. All right, it's when you're in the gizmo, you have the launch screen, and right, if you scroll down, right up underneath it is the assessment. There are 5 questions right up underneath the launch screen, the activity screen. Okay, so there's about 5 of you who need to go back and do that. On the actual, I'm gonna pull it up and show you. Yeah. Mhm. All right, so this is the activity. Right underneath it, if you keep scrolling down, it says assessment questions. They're multiple choice. When you submit, and then when you finish, you submit. And it records it for me, so you don't have to send me the score. I will automatically see it in the Gizmo gradebook. You got it? Okay. All right. So as soon as my little spinny wheel stops spinning, I'll stop sharing because for some reason, when I leave this up too long, it crashes my Zoom page. I have to put in a problem thing for them. Why my share just keeps. All right, so if I disappear because it collapsed, I'll be right. Mhm. All righty. Let me check your message in the chat. Okay. It didn't go through. There's no score. check. I might need to refresh my page. Okay. Thank you. is just about up for today. If anybody needs me to reset something, please let me know. Again, I'm going to stay on, but you all are welcome to log off. Have a great weekend.